Welcome to 1.1 Absolute Value Graphs. Before we start taking some of the notes, let me hop over to Desmos and show you what happens when we manipulate the absolute value graph. So this right here is the absolute value of x. We can do several things to the graph. We can move it around, we can flip it upside down, we can make it skinnier, we can make it wider. So first thing that we have is we have this value h. If you can see where I'm pointing right there. H, if I move this slider back and forth, causes the graph to slide left and right. If you notice, when h is a positive number, even though there's a minus sign in the formula, when h is a positive number, the graph slides to the right. When h is a negative number, the graph slides to the left of 0. So we can do the same thing. Let me get that back on 0. Close enough. With k. Notice k is outside the absolute value graph. And if I manipulate k, when k values are positive, the graph slides up. When k values are negative, the graph slides down. Same thing with a. It manipulates the graph. But a causes the graph to become skinnier or wider. When a is negative, the graph flips below the x-axis. We call that a reflection. It can still be skinny or wide, but it's underneath the x-axis. And because Desmos is super cool, we can animate these and cause our graph to move around and create all sorts of absolute value graphs. So, knowing that, let me hit pause on these animations and we'll head back to our notes. And the first graph that we're going to look at and we're going to analyze is the graph of x minus 4, absolute value of x minus 4. So if I hop back over to Desmos real quick and I pull up x minus 4, there it is. Notice it's slid to the right. So even though there's a minus in x minus 4, the graph still slid to the right, so we call that a shift to the right. And we don't have anything in front of it. We don't have anything behind it, so there are no other transformations. So if we head back to our notes, when we describe our transformations, we're going to say we had a shift right 4 units. Then let's talk about domain. So domain of an absolute value function means what are the x values that the graph is going to hit. So if we start at the center of our v, right there at 4, and we go to the right, this graph is going to continue moving to the right. So I'll just put a little arrow on the end of it. It continues forever. Now that arrow is going up, but we're concerned with domain, which is left and right. So because it's going to go to the right forever, that means that the domain is going to go to infinity. Same thing with the left-hand side. If I start at the 4 and I go up to the left, that graph is going up, but we're worried about left and right because we're talking about x values. So because it's going to the left forever, it's going to negative infinity. So our domain is going to be negative infinity to positive infinity. I wrote this pretty high up in the box because there are other ways that we can write this. Some people say x is in the set of real numbers. So let me define those over here. So this little C with a slash or an E looking thing is in the set of, and the R you may have seen before, the R with the extra bar on the side, means real numbers. And some people will even make this really formal, and they'll put it in curly brackets, and they'll say x such that line means such that. So let me put that over here. So the line means such that. And then we put x in the set of real numbers. For the most part in this class, we're going to use this notation, which is called interval notation. So let me label this. This is interval notation. Okay. So then let's talk about the range. Range can be a little tricky because it's tougher to see. But range asks what's the lowest y value and the highest y value that the graph touches. So when we look at range, sometimes it's helpful to use a highlighter. And since we're looking at y values, I'm going to go up and down on the graph, and I'm going to make highlights. And I'm going to stop when I hit the graph. So what I'm going to look for now is I'm going to take my pencil. That spot right there is where I hit. I'm going to look for the y value that I hit, and that y value is 0. So I'm going to start at 0. I'm going to keep going with my highlighter, and I want to see where I stop. So I'm going to keep highlighting, keep highlighting, keep highlighting. I get to this arrow. Well, this arrow continues up forever. So if I could, I would just keep going forever, which means we're going to infinity. So I actually just made an oopsie. I'm going to erase it. Because when we have a dot that stops us, like we did here at 4, 0, we put a bracket. Okay, and this bracket means included in this interval. So infinity will always have a parenthesis because infinity can't be included. Infinity goes on forever. We never stop and grab it. But 0 can be included if there's a dot there. Okay. So then let's talk relative max and relative min. I'm actually going to go back and I'm going to get rid of this highlighting so that we can clean our graph up a little bit. But relative max and relative min mean the highest and the lowest points around the points around it. So a relative max versus an absolute max means it just has to be higher or lower than the points right around it. We don't care about all the points, we just care about the points right around it. Absolute max and absolute min mean the highest point or the lowest point on the entire graph. So of all of the points that are on that graph, which one is the highest and which one is the lowest? So absolute value actually makes this kind of easy for us because if you look here, this side of the graph goes up forever. This side of the graph goes up forever. But this part of the graph stops at 0, just like we had in our range. So this spot right here is the lowest spot on the graph, so it's a minimum. So the relative minimum, we're going to use y values when we talk about this. We're going to say y equals 0, and the absolute min is also y equals 0. On graphs, they aren't always the same. But on this graph, there's only one point where the graph turns around and changes direction, and it just happens right there at 4, 0. We didn't use the 4 because when we write absolute max and absolute min, we tend to only use the y value. For relative, since we have a minimum here, we don't have another turning point, and so we don't have maxima. So we're going to say none for both of these. Okay. Next, increasing and decreasing. So our max and min are going to help us determine increasing and decreasing. When you think of increasing and decreasing, if I go back up to my graph, I'm going to imagine that there's a person standing here on the top of the graph. There's my person. And this person is going to run, walk, slide, whatever you want this person to do along the absolute value graph. So when this person starts to walk, he's going downhill. Downhill is decreasing. So this right here is downhill. And that equals decreasing. Then when he gets to the bottom of the hill, so the minimum, there he is, he's going to start to walk uphill. And uphill is increasing. So on this graph, the person starts way uphill. I mean, forever uphill. We're talking infinity. And so the person is starting at negative infinity, because we're talking about x values. So increasing and decreasing are x values. And continues to decrease until he hits the bottom of the hill, and that happens at 4. Then, whoops, I went the wrong direction. I apologize. Let me back that up. That was decreasing, wasn't it? Negative infinity to 4. Then we're increasing from 4 on forever, so on to infinity. The next thing we're going to look at is the end behavior. So where are the arrows going? So if we look back up at the graph, we have 2 arrows, one on the left and one on the right. So we've got an arrow here and an arrow over here. The arrow going up and to the left means that the x values are going left, but the y values are going up. So the way we write that is we say x is going to negative infinity and y is going to infinity. On the right-hand side, that graph is going up and to the right. So the x values are going right, the y values are going up. Right is positive, so that's positive infinity. And y, or up, is also positive infinity. Okay, so another way to look at this is what the left is doing, and the y is going up. And when the graph is going to the right, the y values are going up again. Last thing we're going to analyze are the x and the y intercepts. So x and y intercepts are where the graph crosses the axes, either the x-axis or the y-axis. So for an x-intercept, we want to look where the x-axis is and look at where the graph hits it. Well, the graph hits it right there. And so that happens at the point 4, 0. Then we're going to look for the y-axis. So there's my y-axis. And if I go up to where the graph hits it, it also hits at 4. But that point is the point 0, 4. Okay, so these, let's label them, are points. So it can be a little confusing because intervals and points look the same in many cases. So you have to be aware that intercepts are points, and things like increasing and decreasing and domain and range are intervals. So let's try the next one. And now that we're more comfortable with this, it'll take a little less time.